All right, we're going to be talking about inverses again today, and I'm also going to go through verifying with you. So yesterday on example 45, we found the inverse. So f inverse of x equals the fifth root of x minus 3 divided by 2. Okay, when you verify, you have to show two directions. So you're going to want to show f of f inverse of x equals x, and then f inverse of f of x also equals x. So if we show these two statements to be true, then that verifies that yes, we really did find the inverse. Okay, so first thing is, on this first one, you are putting the inverse inside of f. Okay, the inverse goes inside of f. So we're going to take this inverse equation that we found yesterday, and it's going to go inside of function f. So it's going to look like this. 2 times something, we're going to put our inverse in there in a second, to the fifth power plus 3. Okay, so now our inverse goes in, and we're going to simplify. So first thing, exponent. So this exponent of 5 cancels out that root, the fifth root. So we end up with 2 times x minus 3 divided by 2 plus 3. Next step, my 2's are going to reduce, x minus 3 plus 3, and then simplifies to x. Okay, now we're going to go the other direction. So this one says put f of x inside of the inverse. So this time we're going to take f of x, and it's going to get substituted in for the variable in the inverse. Okay, so it's going to look like this. So it's going to be the fifth root of something minus 3 over 2. Okay, so now we're going to put in that f of x. So it's going to be 2x to the fifth plus 3 goes in for where that variable is. And now we can simplify. So in the numerator, you got 2x to the fifth plus 3 minus 3. So those are going to cancel. So you now have the fifth root of 2x to the fifth over 2. My 2's reduce. And then the fifth root of x to the fifth. And again, that simplifies to x. Okay, so there we have verified that yes, indeed, that equation is the inverse. Okay, let's go back up here and look at this one. So we're going to find the inverse. So we're going to put it equal to y, take it out of function notation. Okay, now we're going to swap the x and y. And now we're going to solve for y. So first thing I'm going to do here is I'm going to multiply by 27 on both sides. That's reciprocal, so that's going to reduce out. So 27x equals y cubed. So to get y alone, we're going to cube root, and simplify. So the cube root of 27x. Well, 27 is a perfect cube, so I can do a factor tree. It's going to be 9 and 3, and then your 9 is 3 and 3. So you get 3 3's. So we can simplify this radical to 3 cube root of x. And that is our inverse function. Okay. All right, let's go to example 46. We're going to find the inverse, then we're also going to verify on this one. Okay, so first step, write it as a y equals. And then we're going to swap the x and the y. So x is going to equal 2y cubed minus 6 over 9. And now we're going to work on solving. So first thing here, I'm going to multiply both sides by 9. Okay, so then 9's reduce. So we have 9x equals 2y cubed minus 6. So add 6 to both sides. So 9x plus 6 equals 2y cubed. Okay, now I'm going to divide by 2. So that reduces. So we get y cubed is 9x. If you want to, you can leave it as one fraction. I think I'll just leave it as one fraction, or you could separate it into two fractions. Okay, then last step here is going to be take the cube root of both sides. Okay, so when we clean that up, that cube root cancels out the exponent of 3. So this becomes y equals cube root 9x plus 6 all over 2. So rewrite that in inverse notation. And there's your inverse. Okay, to verify, so we're going to do the same thing we did a minute ago. So we need to show f of f inverse of x equals x, and then f inverse of f of x equals x. Okay, so this first one, the inverse is going to go inside of function f. So here's my inverse, and it's going to substitute in for that x. Okay, so this is going to be 2 times something cubed minus 6 all over 9. Okay, so what goes in that variable? My inverse does. So this is going to be the cube root 9x plus 6 all over 2. Okay, so this cube root gets canceled out by the exponent of 3. So this becomes 2 times this fraction all over 9. So then we're going to be able to reduce again this 2 here, this 2 there. So you get 9x plus 6 minus 6 divided by 9. So again, your x's cancel, and now you have 9x over 9, and that would simplify to x. Okay, now other direction. So this time we're going to take f of x, and it's going to go inside of the inverse. So we're going to do the reverse. So take your function f, and it gets put inside of the inverse. So we're going to have a cube root of 9 times something plus 6 all over 2. Okay, so I'm taking f of x. So that's going to be 2x cubed minus 6 all over 9. Okay, well, simplify under your radical. So those 9s are going to cancel. You're going to end up with cube root. Okay, so we still have this fraction. 2's on the bottom. So in the numerator, you're going to have a 2x cubed minus 6 and then plus a 6. Okay, so then you can see how these 6's are going to cancel out. You're also going to have the 2x cubed over 2, so those 2's are going to cancel out. Okay, now we're down to the cube root of x cubed, and again, that cube root cancels out that exponent of x, and we finish with x. Okay, so there's your verification. All right, on your homework, make sure that you are reading that and following the directions, because I want to see all of it. So I want to see your graphs. I want to see your table of values. You are finding the equation of the inverse, and you are also verifying that equation. Okay, so there's a lot of parts to that worksheet that you all are working on for homework tonight.